Hello, everyone. I got a question from a fellow student in our 171, one of our 172 rather, communities. And she was asking about number 13 on homework 6.1. And this deals with radian measure and arc length. So just got to point out when you're dealing with 6.1, most of the formulas and things that you deal with are going to require a radian measure for any sort of angle rotation, theta, any sort of calculation of arc length or something along those lines. So let's just take a look at what we have going on here for this figure. In this figure, we have you can see we have question 13 here, which has a sort of kind of a pulley kind of system here. So it's like a gear that's going to rotate and a rope or a cable that's attached to this sort of pulley. And the other end is a weight. All right, so it asks how many inches will the weight in the figure rise if the pulley is rotated through an angle of 73 degrees and 50 minutes. All right, so we're thinking about the amount of rotation occurring here. Again, is going to be 73 degrees and 50 minutes. All right, so something to keep in mind is we're going to have to convert that degree measure into radians. But let's talk about what formula we need to use for this. So essentially, this rope is going to be guided along the edge of this circular pulley here. So when you think about like the distance from those 2 points, we would refer to that distance as arc length, because it is the length along the arc of a circle, okay? So we have a formula for arc length. That's going to be S, which represents arc length. It's going to be S equals R theta, where R is the radius and theta is the angle generated by rotation. And we just need to keep in mind that that is in radians, okay? So that's the first question, is how many inches will the weight move when we rotate the pulley? The second question is what angle must be generated in order for the pulley to raise the weight 6 inches? All right, so let's take a look at the first question. Again, arc length is important to solve this. So we go ahead and substitute in the known value. So we can see the radius here is 9.45. So I substitute in 9.45 for the radius. And then for theta, there's a couple ways that you can handle that. I wrote it in this manner so that folks who may not have a calculator that allows them to enter degrees, minutes, and seconds, they can still calculate this given this sort of angle or degree, minutes, and seconds measurement. So I wrote it like this. So it's the degrees plus the minutes divided by 60, and that will convert it to decimal degrees, okay? So then you can see on the tail end here in yellow, I multiply this by pi over 180 because this is the catalyst for converting degrees to radians, okay? So I end up with 12.177 and some change, but the problem asks for us to round to the nearest tenth. So I go ahead and round to the nearest tenth and I get 12.2 inches. So if I rotate this pulley on an angle of 73 degrees and 50 minutes, this rate will move up a distance of 12.2 inches. All right. Now, the second part of the question wants us to determine the angle that this pulley must be rotated to raise the weight 6 inches. So it's obviously going to be less than 73 degrees because, 73 degrees raised at 12 and something. So since it's less than that, then it should be definitely less than 73. So the second part, ask us to pretty much calculate the required angle to raise that weight. And we still use the formula for arc length. So we still have S equals R theta, but we're going to rearrange this so that we can isolate theta and determine what that angle is. So it ends up being theta equals the arc length over the radius. And you need to remember this is going to generate something in radians, and you need to convert that to degrees, minutes, and seconds You can't see it here, but if you worked out this problem, you know the second question wants you to provide degrees, minutes, and seconds, rounded to the nearest minute as needed. So we go ahead and substitute in the values. We know the arc length is 6 because that's the amount of rotation we're trying to, or that this pulley has been rotated through. So the arc length is 6. The radius is constant, so that's going to be 9.45 here. And if you notice, I'm multiplying this by 180 over pi. This is the catalyst to convert radians to degrees. So I go ahead and calculate this, and I get 36.378 blah 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 degrees. The way that I sort of convert this to degrees, minutes, and seconds is I will take that whole number you get in your calculator, I will subtract the whole degree from it. So I'll subtract 36, and then I would just multiply everything after the decimal by 60, and I round it to the nearest minute and got 36 degrees and 23 minutes. So to Charlotte, who answered or asked the question, I hope this helps, and feel free to request any videos on completing complicated problems. And just to kind of let you guys know, I know I have a very strict late work policy, but I still would like you to go back and complete homework even if it's past the due date, because homework is just so critical to your understanding. So as far as homework and discussions, even if it's past the due date, I would like for you to make your contribution, because that's helping our learning community. Although I would warn against making it a habit to submit late work. So hope this helps, and I will hope to talk to you all in the future. Peace.